In this video, we will learn what the empirical rule says about the distribution of bell-shaped data for specific intervals in the dataset. When a distribution is bell-shaped, the following statements are true. Approximately 68% of the data values will fall within one standard deviation of the mean. Approximately 95% of the data values will fall within two standard deviations of the mean. Approximately 99.7% of the data values will fall within three standard deviations of the mean. Let's begin with the first statement. One of the characteristics of a bell-shaped distribution is that the distribution is symmetric on either side of the mean. If we add one standard deviation to the mean, we can establish an interval endpoint to the right of the mean. If we then subtract one standard deviation from the mean, we wind up with a left endpoint for the interval. Everything that falls inside of this interval would be within one standard deviation of the mean. The empirical rule tells us that this would represent 68% of the entire data set. Now let's add one more standard deviation to the right-hand interval endpoint and subtract one more standard deviation from the left-hand interval endpoint. This would result in an interval that would contain all of the data values that are within two standard deviations of the mean. The empirical rule tells us that approximately 95% of the entire dataset would fall within this interval. Extending one more standard deviation on each end of the interval would create a new interval where all of the data values are within three standard deviations of the mean. The empirical rule tells us that approximately 99.7% of the entire dataset would fall between these interval endpoints. In this video, we learned what the empirical rule says about the distribution of bell-shaped data for specific intervals in the dataset.